And so on 13, I told you everything that I want. So vertical asymptotes. Vertical asymptotes are x equals whatever makes the bottom 0. If you set the denominator equal to 0, you get a positive and negative 2i. Can you have imaginaries? No. So that just means there is no vertical asymptote. Okay, how do we find horizontal asymptotes? The limit as x approaches positive and negative infinity. We've talked about how those can be different things as long as you have a polynomial or just a rational function. They will be equal, so you can do them both at the same time. But you do need to somehow show me that you are aware there are two of them. So either put plus or minus infinity or write the two out separately. If I just plug in, I get infinity over infinity, which doesn't work. So what can we do? We divide it by the highest power of x on top and bottom. We get 1 minus 4 over x squared, or 1 plus 4 over x squared. When you plug it in positive or negative infinity, you get 1 minus 0 over 1 plus 0, so we just get 1. So our horizontal is y equals 1. Critical points. To find those, you have to find out anywhere the derivative is 0 or undefined. So it is a fraction, so we have to do quotient rule. So low, d high, derivative top is 2x, minus high, d low, over low squared. So we get 2x cubed plus 8x minus 2x cubed plus 8x. So we get 16x over x squared plus 4 squared. Okay, so critical points, what would make it 0 or undefined? We know it's not undefined. We already checked that when we did the asymptote. What would make this thing equal 0? Yeah, the only thing that makes the top 0 is 0. So then we have to find increasing, decreasing, maximums, and minimums. So that's when we did the sign line. You put your critical points on there. You are plugging test points into the derivative. So if I put in a negative 1, the top is positive, the bottom's positive, so that's positive. If I put in 1, positive and positive, it's positive. Hold on. That's not a 16x squared, is it? That's supposed to be a 16x. So this turns out to be negative. How long were you guys going to let me go with that? Just a little while? Okay, so this one is increasing from 0 to infinity, decreasing negative infinity to 0. Okay, make sure you guys know how to do all the pieces on these graphing questions. This is a lot of points because there is a lot involved here. Now decide if it's a maximum or minimum. If you're decreasing and switch to increasing, what do you get? Local min at 0, comma, how do you get the y value? Plug it in for x in the original. I did not write down my original problem. So if I put in a 0 in the original, you get negative 4 divided by 4, which is negative 1. So to get the actual ordered pairs, you always go back to the original equation. Okay, so we've done increasing, decreasing, maximum, inflection points. How do we get inflection points? Second derivative. So starting here, we have low, d high, minus high, d low. So the 2 comes down, inside stays the same, subtract 1 from the power, times derivative of the inside. All over low squared, which would make it to the 4. We can cancel a little bit. We have an x squared plus 4 in all of these. So if I cancel that, multiply, this would be a 4x times 16x be a 64x squared. So we get negative 48x squared plus 64 over x squared plus 4 cubed. Inflection point is where that derivative is 0 or undefined. So it's never undefined because the denominator doesn't equal 0. We've already done that a couple times. If you set the top equal to 0, if you divide the 48 over, what do we get? 64 and 48. They're both divisible by 16. Square root, plus and minus. Square root of 4 is 2 over the square root of 3. Plus and minus 2 radical 3 over 3. Those are the inflection points. So to check concavity, we do a sign line for those. So if you put in something smaller, what is this as a decimal? 2 radical 3 over 3. What is that? Okay, so something smaller would be like negative 3. In between them, maybe a 0. Bigger, maybe a 3. Where do I plug these in? Second derivative. Okay, so if I put in a negative 3, the top is negative, the bottom's positive. If I put in 0, positive over positive. Put in a 3, negative over positive. So we are concave up from negative 2 radical 3 over 3 to positive 2 radical 3 over 3. Concave down on the ends. Negative infinity to negative 2 radical 3 over 3. Union 2 radical 3 over 3 to positive infinity. Okay. So, the graph. We don't have any vertical asymptote. The horizontal was at 1. We had a minimum at 0, negative 1. Our critical points, if we plug these into the original, we get the actual ordered pairs, which you need to do. So on the final, I'm probably going to have to give you something a little bit nicer. But if I plug that in, okay, so we get kind of in this area for our inflection points. And then our graph, that's where we change. We are decreasing first, and we are curved downward. So decreasing and curved downward. Then we're still decreasing, but we're curving upward. Then we're increasing and curving upward, then increasing and curving downward. So it looks like this. So make sure you are marking your inflection points, your maximums and minimums, your asymptotes, all that stuff you find, I do expect you to plot on your graph. Any questions there? Next up we have problem 15. So limits, 15C. So if I just plug in, I get 0 to the 0 power. Do we know what that is? No. So this is when we apply L'Hopital's rule. Now, L'Hopital says if you have a fraction in indeterminate form, so 0 over 0 or infinity over infinity, you can do the derivative of the top and the derivative of the bottom, and then apply your limit. When we had like products, we had to move one of them to the bottom, so we would have that fraction. You know, when things were subtracted, we would get a common denominator, so we can put them together and have a fraction. How am I going to turn this into a fraction? What did we add? A natural log. So, our trick was to add the natural log to this. But because I added a natural log, what cancels the natural log? E. So at the end, my answer will be e to whatever power I get, because I have to cancel my log out. The reason I like the log is because properties of logs, exponents drop down in front. Now this isn't overall, I mean, it really hasn't helped me much because it's still 0 times, as you approach 0, the natural log is going to negative infinity. We don't know what 0 times infinity is. But now it's a product, so we move one of those to the denominator. So if I wanted to move that down, it would become an x to the negative 1/2. Alright, are you guys with me so far? So the top, as you approach 0, natural log is going to negative infinity. On the bottom, this is like 1 over the square root of 0, so that's going to infinity. So that's the indeterminate form for L'Hopital's. So now we can do the L'Hopital's, and I asked you to label when you do it. Derivative of the top, derivative of a natural log is 1 over x. Derivative of the bottom would be 1/2 x to the negative 3/2. So if we clean this up, okay, if I wanted to flip and multiply, that would be a negative 2 over 1. X to the negative 3/2. If I bring it up, it's a positive 3/2. So we get negative 2, x to the 3/2 over x would be x to the 1/2. Can we plug in now? You get negative 2 times the square root of 0, which is 0. So my final answer is e to the 0 power, which is 1. So when it was an indeterminate power, you have to add the natural log, and then your final answer is e to that power. Is that okay? Okay, 16. So looking at this, your domain, what can x not be? 0. So x can't be 0, so your domain is everything but 0. Part B, x and y intercepts. So an x-intercept is when y equals 0. So if you plug in a 0 for all this, or for your y, a lot of these we did use our graph to find some of these things because they weren't pretty. So just know, like on your final, I have to give you pretty ones because you don't have that graph to help you. If you took everything times x squared, there's nothing that multiplies to 1 and adds to 1. If you try to do the quadratic formula, what are you getting under your radical? A negative. So it's imaginary. So what does that tell me about my x-intercept? There is. You could also, you know, if you were looking at a graph, you would see it does not cross the axis there. Y-intercept, you have to plug in 0 for x, but if you do that, can we have that? So there is none. Part C, symmetry, I really meant to take that off your study guide and I forgot. You would just look at the graph, but on test you guys don't have a graph, so I'm not going to ask you symmetry. I'll just tell you that right now. So I'm just going to skip that. So D, asymptotes. So vertical asymptotes happen when you are undefined. So we already said that happens at 0, so that's our vertical. To get your horizontal, like we did on the previous one, you have to do the limit as you approach positive and negative infinity. And this is written really nicely for that because a number over infinity always turns into 0, so you get 1 plus 0 plus 0, which is 1. So our horizontal is just y equals 1. Okay. Next thing I asked for was increasing, decreasing. So we need our derivative. So if you do this derivative term by term, the 1 would cancel. 1 over x, that's like x to the negative 1, so that becomes negative x to the negative 2. 1 over x squared, that's like x to the negative 2, so that becomes negative 2x to the negative 3. So if we find our critical points, that's anywhere this is 0 or undefined. So we could add one term over, cross multiply. If we get everything on one side, what can we do now? Take out x squared. So our critical points are at x equals 0, which is technically what made it undefined, and negative 2. So to find increasing and decreasing, you do your sign line. If I plug these into the derivative, make sure you're using your actual derivative. So if I plug them in here, I will get a negative 1/3 minus 2/9. So this would be a negative. Put in negative 1, get negative 1 plus 2, so that's positive. Put in 1, negative 1 minus 2 is negative. So this one is increasing between negative 2 and 0. Decreasing negative infinity to negative 3. Union 0 to infinity. Our f was the maximum or minimum, so if we look here, it went from decreasing to increasing, so that is a local max. To get your y, you plug the negative 2 into the original, so you get 1 minus 1/2 plus 1/4, so that would be 3/4. Is everybody with me on these? At 0, it goes from increasing to decreasing, which would be a local max, but what happens if you try to plug 0 in? You can't, so there isn't a maximum. Then I asked for the concavity and inflection points, so we need our second derivative.
Isn't it supposed to be a local min?
Yes. Did I say min and write max?
Yep. Is decreasing to negative 2 or negative 3? Under decreasing.
Thank you. Okay, let's try this. Second derivative. So I'll go here. So the negative 2 comes down, so that gives me a 2x to the negative 3. Negative 3 comes down, so that's a 6x to the negative 4. rewrite that as like 2 over x cubed plus 6 over x to the 4th. The last one, I just set this equal to 0 and solve it that way. If you are more comfortable, you could also get a common denominator and put these together. If you chose that route, you would have to take this one times x on top and bottom. So you get 2x plus 6 over x to the 4th. So whatever makes the most sense to you. If I'm looking at it that way, the inflection points, what makes the top 0? -3. What makes the bottom 0? 0. So we'll get them either way. So if we check our concavity, plug them into our derivative. So if we put in -4, negative over positive is negative. -1, positive over positive. 1 is positive over positive. So you are concave down from -infinity to -3. Can I just say that I am concave up from -3 to infinity? No, because we are undefined at 0, so you do have to go ahead and separate those. If you got your actual point for your inflection point, when you put in -3, it comes out to be like 7/9. So we'll need that when we draw our graph. But the 0 is an asymptote, it's not an actual point on our graph anyway. And so now when we draw our graph and plot all of this stuff, we don't have any intercepts. We have a vertical asymptote at 0 and a horizontal at 1. Okay, we have a min at -2 3/4. We have our inflection point was at -3 7/9. So this is going to be kind of tricky to draw, isn't it? Okay, so then if you use your calculator to kind of fill it in, but we don't even need to because we have everything. We know that we are decreasing until we get to this point. We know we are concave down. So decreasing but concave down kind of looks like this. Then we're concave up, but still decreasing. And then after this point we start increasing and we're still concave up. So you're crossing your horizontal asymptote, it looks like that. After 0 we are decreasing again and concave up. So decreasing but curved upward. Looks like that. So not a very pretty one, but it works. Questions there? 17 and 18. So problem 17. A farmer has 600 meters of fencing with which to build a rectangular corral. So I'm going to draw a rectangle. Some of the fencing will be used to construct 2 inner divider fences, both parallel to the same sides. What is the maximum area? Okay, so it's a rectangle. That means all of these are the same, and these are different. We have 600 meters of fence, so what do I do? Add all those up, 4x plus 2y, and it equals 600. I want the maximum area. Area is length times width, so x times y. Before I need this, I can do this derivative, I have to get rid of a variable. So we can use this equation and solve for one of them. So y is 300 minus 2x. So plug that in, I'm going to go ahead and distribute. Then, anytime I ask you for maximum or minimum, what am I asking you to do? Derivative. So the derivative of 300x would be 300 minus 4x. And to find that derivative, or to find the maximum or minimum, we set the derivative equal to 0. So divide, and we get 75. So then we had to answer, I wanted the actual area. So you can plug your 75 into your area equation. If you wanted, you could find your y first. It really doesn't matter. You get 300 minus 150, so that's 150. So your area is 75 times 150. And 75 times 150 is, and area is always square. Yes?
Are these the ones that you want in sentences? Like,
Yes.
sentence?
Word problems I prefer a sentence. If I give you words, answer words. Okay. Last question for the day. So, suppose you are making a rectangular box with a square base. So, here's my box. If it's a square base, that means these sides are the same. I don't know how tall it is. I'm going to call that y. The material for the top and the four sides costs $1 per square foot. The material for the base is $2 per square foot. Find the dimensions of the box at the greatest possible volume if you are allowed to spend $144 for the materials. So volume is length times width times height. I need to get rid of one of these variables before I do it. That's where the cost comes into play. So I have $144. The base, that's this bottom, costs me $2 per square foot. So to find the cost of that bottom, you do the area times 2. So 2 times length times width would be x squared. The top and the sides each cost $1. So for the top, the cost of the top is $1. Area of the top, length times width, is x squared. Sides, are all my sides the same? They're all x times y, aren't they? So I'm just going to do, there are 4 of those. They cost $1, their area is xy. Is everybody with me so far? So if I want to solve for y, we do 144 minus 3x squared. So y is 144 minus 3x squared over 4x. So we will plug that in for the y. Okay, this looks fairly ugly, but it's going to clean up alright. We can cancel one of the x's. 144 divided by 4 would give me 36x minus 3 over 4 x times x squared is x cubed. So our derivative, to find maximum or minimum, you do derivative equal to 0. So times 4 over 9, 36 divided by 9 is 4, times 4 would be a 16. Square root, plus or minus, but can we have a negative here? No, so it's 4. Then I wanted the dimensions of the box. So x is 4, so length and width are both 4. The height was your y, so if you plug in a 4 here, you get 144. 16 times 3 is 48 over 16. So 96 over 16, which is 6. We have gone over like the really time-consuming problems so far. Those word problems, the graphing ones, those are the time-consuming ones. So even though you still have like half the study guide left, a lot of these are going to go fast. It's just, you know, integration, those kinds of things. So that shouldn't be so bad. Do you guys have any other questions for me on this part? So I am not going to go over any tomorrow. Thursday we will go over the rest of it. So please have the rest of it attempted for Thursday so we can see our questions. Also, if you